This is the third lecture of the design of beam. So students, in the last lecture, we have to discuss about which are the loads have to be considered while designing any beam. And after that, we are starting our example number 2. So the question of example number 2 is this, and in the last lecture, we are already discussed that how to give beam numbering and column numbering, in which at last we have to decide that in this example we have to design beam B 18, 19 and 20. Okay, so students, as per this figure, you can see that your beam number B18 and beam B20 is the mirror image of one another. So, if we have to calculate the load on beam B18, then it is obviously the same load on beam B20. So, the first question is, the beam is supporting which types of slab? So you can see that this is one-way slab on the left side, and this is also the one-way slab on the right side. It means your beam B18 and beam B20 is resting, or it supports beam B18 and 20 support the both the one-way slab. It means on beam B18 or beam B20, half of the load coming from left side of slab and half of the load is coming from right side of the slab. Okay. Now, what is this length? This length is 3 meter. You can see that this length is 3 meter. So, from 3 meter, 1.5 meters load is going to beam B16 and 1.5 meter load is going to beam B18. And similarly, from right side of the slab, half of the load is going to beam B18 and half of the load is going to beam B20. Now, we have to design, or we have to calculate the load on beam B18, which is equal to beam B20. So students, it is already discussed that in the question that the thickness of slab is 115 mm for all the slab, whether it is one-way slab or whether it is two-way slab. So in dead load, there are four types of load. First is sulfate of slab, floor finish, masonry wall load, and sulfate of beam rib, in which first two load, sulfate of slab and floor finish, is in kilonewton per meter square. So let us start. We have to calculate these two loads. So the sulfate of slab, which is rho into capital D, so the density of concrete is 25 into capital D, so it is 0.115, because 115 mm is the thickness of slab. So students, our answer of sulfate of slab is 2.875 kilonewton per meter square. And after that, the floor finish is equal to 1 kilonewton per meter square. So students, our total dead load, which is always remain steady, because our thickness of all the slab is remain same and floor finish is also remains same. So our these two dead load is always remain same for all the slabs, which is 3.875 kilonewton per meter square. Now we are moving further to the load calculation on beam B18 is equal to beam B20. So students, there are four major loads, in which first two loads is 3.875 kilonewton per meter square. But it is already discussed that from 3 meter span, 1.5 meter from left side and 1.5 meter from right side. So total 3 meters load span is taken on beam B18. So the dead load from slab is equal to 3.875 into 1.5 plus 1.5. It means 1.5 from left side and 1.5 from right side. So total dead load from slab, so is equal to 11.625 kilonewton per meter. Second one is self weight of beam rib. So students, the equation of self weight of beam rib is rho into B into capital D. This calculation is already discussed in our last lecture that rho is the density of concrete. Our B is equal to width of beam, and in the last lecture we have to assume that the size of beam is equal to 230 mm, so it is 0.23, and your capital D is the total depth, but your capital D over here is zero point 0.3 is your total depth, in which 0.115 is your thickness of slab, which is already calculated in the dead load from slab. So our beam rib means luttock portion is 0.3 minus 0.115. So students, after putting all this value, we have to calculate that your self weight of beam rib is 1.06 kilonewton per meter, and our last load, third load, is masonry wall load. So the equation of masonry wall load is rho into B into capital D. Now masonry wall load, it means brick wall load, so the density of brick is 20. Now you can see that there is two types of wall. First one is external wall, which is constructed on the periphery of the building, and other is internal wall, which is inside of the building. So this beam B 18, 19 and 20 takes the load of internal wall, because this is your internal beam. Okay, so 20 is the density of brickwork. Your thickness of internal wall is equal to 150 mm, so it is 0.15, and your capital D. So you can see that this is your floor height, which is equal to 3.35 meter, in which your brickwork is started from the bottom of the beam. So we have to deduct the depth of bottom, which is 0.3. So after putting all this value, we have to calculate the masonry wall load, which is 9.15 kilonewton per meter. So students, this is all the dead load. Now the total dead load is 1 plus 2 plus 3. So it is 21.385 kilonewton per meter. But this total dead load is unfactored load. But we have to design all the components for factor load. So our factor dead load is 32.75 kilonewton per meter. So this is the factor dead load. Now we are moving further to the live load calculation. So in the question, it is clearly mentioned that your live load is equal to 4 kilonewton per meter square. But as per the calculation of dead load, the similar calculation for live load as half of the load from left side of slab and half of the load from right side of slab. So your live load is 4 into 1.5 from left side and 1.5 from right side. So it is 12 kilonewton per meter, but this 12 kilonewton per meter is also a unfactored load, so your factored live load is 18 kilonewton per meter. Now the total load on beam B18 and beam B20 is the total dead load plus total live load, so it is 50.75 kilonewton per meter. So students, this is the calculation of the load on beam B18 and beam B20. Now our last in middle beam is beam B19. So you can see that this is your beam B19, which takes the load of this two-way slab and this two-way slab. Okay, so this length is 4 meter and this length is 6 meter. So the load distribution theory, in which there is three types of slab beam supporting three types of slab. In second type of slab, when the beam is supported the two-way slab. The shorter span takes the triangle portions load and the longer span takes the trapezoidal loads. So you can see that in this example, this is your beam B19. So this length is 4 meter and this length is 6 meter. So this beam B19 is the shorter span. It means this slab's triangle portions load is going to beam B19, and from right slab also the triangle portions load is going to on beam B19. It means two triangles load is going to on beam B19. So you can see that beam B19 carry triangle load from two ways left from both the side. Okay. So students, our dead load calculation in which first two dead load, self-weight of slab and floor finish is already calculated as 3.875. So whenever there is a triangle load, the equation is W into Lx by 3. But this is the equation of one triangle. Now on beam B19 there is two triangles load. So the equation is 2 into W into Lx by 3. So 2 is constant. W is 3.875. Lx is equal to 4 meter divided by 3. So you will get your answer 10.34 kilonewton per meter. Now your second is self-weight of beam rib. So students, the size of beam is remain same for all the types of beam and all the types of slab. The thickness of slab is remain same for all the slab, whether it is one-way slab or whether it is two-way slab. It means your self-weight of beam rib is remain same as calculated on beam B18 and beam B20, which is 1.06 kilonewton per meter. And last one is masonry wall load. Now, rho is the density of brickwork, which is 20, and you can see that your beam B19 is also carry the internal wall loads. So it is B. B is equal to 150 mm thick wall load, and your D. D means the height of brickwork, which is the total height, which is floor height minus the depth or the depth of the beam, which is 300 mm. So your masonry wall load is 9.15 kilonewton per meter. So now, after finding out the self-weight from slab, masonry wall and self-weight of beam rib, our total dead load is the summation of all the loads, which is 20.55 kilonewton per meter. But this total load is the unfactored load, so our factored load is 30.82 kilonewton per meter. Now, after calculating the dead load calculation, now we are moving further to the live load calculation, in which the pattern of live load is remain same as dead load, because the beam B19 takes the triangle loads from both the direction. So the live load is equal to 2 into W into Lx by 3. Now 2 is constant. W, so our live load is equal to 4, Lx is equal to 4 divided by 3. So students, after putting all this value, we will get our answer 10.66 kilonewton per meter. But this live load is unfactored load. So our factored live load is 16 kilonewton per meter, and total load on beam B19 is the summation of dead load plus live load. So our dead load, factor dead load is 30.82 and factor live load is 16. So our total load on beam B19 is 46.82 kilonewton per meter. Now this load is represented on figure. So this is your main plan, in which if we are see this figure from this side to this side, this is your column, this is your beam, this is your column, beam and column. So you can see that this figure like this, because you have to see from front side, from this side. Our first beam is beam B18 having span of 6 meter. Your second beam is beam B19 having span of 4 meter, and our last beam is beam B20 having the span of 6 meter, and the load which is represented on this figure is on beam B18 and beam B20 it is 50.75, and on beam B19 it is 46.82 kilonewton per meter, and this is column. The height of column is equal to the height of floor, which is 3.35. So this is 3.35, this is 3.35, this is 6, 4 and 6 meter, and all the junctions is considered as fixed support. Okay, so students, this is the end of our step number 1, which is the load calculation. In the next lecture, this is beam, and you all know that in SA1 and SA2, there is mainly two types of beam, determinate beam and indeterminate beam, in which there is lots of methods like slope deflection method, moment distribution method, Macaulay's method, and all these methods. But moment distribution method is the most precise method. So in this example, whenever we have to design for beam, then we have to refer moment distribution method. So in the next lecture, we are moving further for the moment distribution method and the width, and with the help of moment distribution method, we have to design for beam B18, 19 and 20. Okay, so students, this is the end of today's session. Thank you.